So we were supposed to have Steve Bellevin today from Bell Labs, who worked on Usenet and computer security. I apologize. There was a schedule mix-up, and Steve wasn't able to make it. So I improvised. That's what I'm best at. We came up with the idea to have a panel discussion on homebrew computing. To most hobbyists, homebrew means S100 or kits or whatever. But I was interested in people who actually made computers from scratch. And since he called me out this morning in his speech, I'm going to call him out now, Bill Hurd. Someone who made a computer, the Commodore 128. So if you ever use a C-128, thank Bill. We have Jon Chapman, known as Systems Glitch in the hobby. We have Alexander Pierson, known as Z, and Bill Dudley, known as Dud. Bill made, back in the 70s, a clone PDP-8, which is now in our museum. Alexander made the Cactus 6502 last year, which is just mind-blowingly awesome. And Jonathan made this 8085, correct?
Yep.
8085 single board computer with the VCF special edition. Why don't you take 5 minutes each and talk about what inspired you to do the crazy thing to make your computer from scratch?
I built a scratch machine starting in about 1976. And at that point, the hobby was established. I mean, there were S100 machines, I think SS50 by then. There were Apple IIs, and I don't know what else was running around by 1976. But the point is, you could actually go to a computer store in 1976 and buy a computer. And you could buy kits online. But my best bud and I looked down our noses at all the hobby computers because we said, what good is an 8080 with 4K of RAM that runs tiny basic when we could make a PDP-8 and have Fortran, a real language, and big memory, 32K. So Intersil, I mean, what made it possible was Intersil came out with a chipset that was the 6100 chip and the support family. And with those chips and some RAM, you could make a PDP-8. You could make a PDP-8 that size. And so we decided to do this, but we wanted to make it, like, serious. And we had a PDP-8. Another thing that made it possible, we had real PDP-8s. My friend was going in the PhD program at Duke at the time, and the electrical engineering building had PDP-8s for the students to muck about with. And at this point, they were old computers because this is the mid-'70s, but still, they were usable. And there was even an 8 carcass that people were pulling parts out of. So we managed to get. So the bus on that 8 that I built was chunks of flip chip backplane from this 8 carcass. The flip chip was DEC's replaceable modules in the beginning before there were even ICs. They would make a circuit board about yay big, and it'd be a flip-flop. And it would be resistor-transistor logic, because it would be built with discrete resistors and transistors. And they'd have a backplane, a huge backplane with these flip chips in it, and it was all wire-wrapped. And that's how the very early 8s were built. And then later, as the technology improved, the 8s were built with integrated circuits. So there was flip chip backplane, and if you took a chunk of it and ripped all the wire wrapping off, which was just essentially random connections as far as we were concerned, and we just soldered wires down the length and connected all the pins in parallel so it looked like a bus. And then we sometimes etched and sometimes hand wired our own cards, like we etched memory boards because we weren't masochists. But we hand wired like the serial, the UART serial interface because we only needed one for me and one for him. So hand wiring 2 of them wasn't that big a deal. And I bought 2102 RAMs, cheapo closeout mail order, guaranteed. Nine out of every 10 are probably good, and use those to populate our boards because we weren't made of money. And that's how we built our 8. And the impetus was that we could then get the paper tapes of all the DEX software. We had the focal interpreter, which was like BASIC, but it was DEX interpreter. We had compilers and assemblers and debuggers and every piece of software you'd expect on a modern computer. Well, on a real computer in the late 70s, we had available to us, and we weren't limited to tiny BASIC and tiny this and tiny that and all the nonsense that the 8080 people had to deal with. And so that's how we ended up building our machine. That was the impetus.
All right, I can think of 3 different little chunks that kind of had to coalesce here to inspire the Cactus. Initially, it was seeing a lot of these machines here with front panels, and I was absolutely fascinated by them. But there was always that fear of, number one, I don't know how to use this thing whatsoever, and number two, I imagine people are going to be very guarded about these machines that they're in their possession. These must be very delicate. I don't want to touch anything and ruin anything because I don't know what I'm doing, and they're going to want to keep me back. So that was the first part. The second part was, I think it was 2015, I came here and saw an OSI 300 on display as part of a small little SBC exhibit. I can't recall precisely who had it, but it might have been Bill Sudbrink. Maybe? No? All right. Maybe. Yeah, that was it. And I saw, for the first time ever, a 6502 paired with switches. And you can do that? Oh, all right. That sounds interesting. And it wasn't until that final piece came into play a couple years later, I saw a guy by the name of Grant Cyril has a minimal 6502 machine. And the way his machine was put together, it included a very easy to understand memory map. And finally, the concept of a memory map wasn't this, dark art. It made sense finally. And so I realized, number one, why aren't there more 6502 machines that are like that OSI 300? Number two, I wonder if you could combine that with that simple little machine that's got serial and not much else. Can those be glued together into something? And number three, looking at the OSI 300 and later a small kit that was made by a guy by the name of Christopher Bachman, a miniaturized OSI 300 with very, very tiny, hard-to-use switches and just a very simple interface like the original, but with a little more RAM. I realized there's some way that this could all be made better. I wonder if I can take a crack at it. Maybe this is something I can do. And I guess there was a secret final fourth thing in there. I was at the store one day, electronics store, and I'm looking through their parts, and I see what looks like a strip of 35 Veroboard lines. And I thought to myself, can you fit a 6502 backplane on that? The answer is yes. I bought it, I took a look at it, and started analyzing, okay, can I put something together like this? Yeah, it worked out. But I guess it was that curiosity of, can this truly be done with all of the things that I've seen here? Can I make that full front panel? Is this even possible? To explore myself, for myself, and either try and fail and learn why you can't, or succeed and have something fun to play with.
All right. Well, I ended up building a 6502 system because sometime in middle school I ended up with a dead board out of a Merlin phone system, and it had a 8085 system, not 65. 65.2 on the brain now. 8085 system because I ended up with a Merlin board out of a PBX that had one on it. So I was able to find a data sheet on that through the library back when you had to go to the library for such things, and realized that it was basically the same thing in all these early microcomputers I'd heard about, but only needed 5 volts and no support chips and all that. So around, I guess, 2010 or so, I finally actually built that system, and had a good time building it, learned a lot, and thought to myself, it'd be great if we had a sort of a kit based around this where new people could sit down and build themselves a computer that was easy enough to understand but actually complex enough to be useful. And it's sort of the same thing with Z encountering some of the smaller single boards. Like, well, we could probably make this generic without making it too complex, and run basic and maybe CPM and all that. So that's what I started on. You can see, I think I have a picture of the first version of it. That's a great big heap of wires.
Beautiful.
It's something. It's hard to work on, but yeah, that's gone through like 4 different evolutions, and now it's hardly a homebrew now. It's turned into a kit. So I guess that's the end game for being a homebrew. But yeah, that's what got me started, was being handed this board with this processor on it and looking it up and figuring out what exactly it was and how it wasn't the same thing that was in my 286. And yeah, so that's why I did it.
So for you, it's sort of just, a kit endeavor. Sorry. Sorry about that. So for you, it's a kit endeavor. Alexander, for you, was an educational experience. And Bill, for you, was to really have. What do you guys do with your computers?
Mostly, I worked on it. Mostly, for example, we started out with a paper tape reader interface and a slow paper tape reader so we could read all those wonderful deck paper tapes in and run them. And of course, the first one you have to load in and run is the memory chester. And eventually you'd get enough of the 2102s all working at the same time that you could have some memory, and then you could try loading bigger programs. And the aim was to end up with a real computer, and we wanted to get OS 8 running. And OS 8 was like CPM or MS-DOS. It's a program loader. And in fact, if you've used CPM and you remember the pip copy program, well, that's directly lifted off of DEC's interface. If you sat down in front of OS 8, it would understand pip immediately. So the problem with running OS 8 is that you needed some kind of mass storage, and the canonical mass storage was probably DEC tape, which is 1-inch wide mag tape. And we found these PHY decks, which are digital cassette decks that were designed for computer use. So they were a step above your Radio Shack 1995 cassette deck that you would.
When you say digital, you mean the company, or just mean digital?
No, I mean no, the company was not digital. Yeah, it was meant that they were meant to write ones and zeros. They weren't meant to do audio. And they had a yes. Very possibly. I've lost that neuron's gone. You still have your FIDEX. Anyway, they also had a digital interface where you could control, rewind, play, etc. So you could, in theory, build an interface board to your computer, and then you could read and write anything to mass storage. So we eventually got OS 8 to boot off the FIDEX, and it was painful. It took forever to boot up because the cassette tapes were not anywhere near as fast as DEC tape. And I'm sure it was painful on DEC tape, but it was unbelievably painful on the FIDEX. Anyway, most of the time we spent with the computer was making the computer a better computer. It's not clear how much actual computing I did on the thing. But it was the gateway drug to more computers. And eventually I got to the point where I could actually do useful work on the computer. So there was eventually a time when I was not just fixing the computer for the computer's sake.
Well, when you did actual work, what was it?
Embedded systems programming is a lot of the work I would do, meaning compiling stuff to run on an even smaller machine. That was my career for many years. And so in the early days, you were often compiling on a machine that had the same CPU as the thing you were building. So you were building an 8080 based toaster. You would have an 8080 based development system. So you weren't cross-compiling. You were just compiling for your target and then downloading it or burning a ROM, sticking it in your toaster and seeing if it would make bread. And so that was probably the earliest work I did on the thing.
Unfortunately, a couple of times we tried bringing this computer to demos, and every time I call Bill and ask him how to use it, he goes, "I don't remember."
Well, there's a lot of that machine that, I mean, if you're talking about the PDP-8, the FIDEX stuff didn't last long. I think I had floppies attached to it for a while, and that, by the time that I got to that, I moved on to a Z80-based machine, because by the early 80s, the software on 8080 and Z80 stuff had caught up. You could get a Fortran compiler, or a C compiler, even better. So then the attraction for running OS 8 or DEC software was a lot diminished, because now you could have real languages and real things on an S100 computer. And so I moved to that because there was more hardware availability, and it was more robust than my homebrew stuff.
In terms of what I've actually done with mine besides develop on it, oh man, probably play with BASIC is the thing I focus on the most when things are running correctly. I actually spend most of my time debugging and adding in new features to bring myself up to what I consider the same level of spec as the equivalent machines of the era that I'm trying to build for. So very late 70s, and occasionally I'll add something that's early 80s if I'm feeling, up to the task. But it's really, most of my time is just spent fixing the things that I break without realizing what I'm doing, because it's a very much a learning process for me. And putting together stuff in 6502 assembly to play with the front panel. Coming up with reasons for myself to sit there and toggle something, or more importantly, to use it for more than just data entry. So it's been honestly, it's a lot of development time. But when I'm not doing that and I'm playing with BASIC, it's trying to make funny sounds, because I did build a sound card not too long ago based on the SAA 1099, which is basically half of a creative game blaster or a creative music system. I was like, this is kind of a lost sound chip. I love the way it sounds. It's quite different from its contemporaries. Well, let's explore what that can be like. But it's a lot of just writing simple little demo programs to kind of push the limits of my understanding and improve on the features here and there, because honestly, there's still a lot of distance for me to cover before I have what I consider to be a functional, complete Cactus. And that's not, obviously I can feature creep forever, but there are a few set things that I need to accomplish before I feel like I'm happy with it. And one of those big ones right now that I've been focusing on for, gosh, the last couple months here is software-controlled switches on the front panel without interfering with everything else that's going on, and to do it without having to use more fancy chips than 7400 series logic. Because I find the 7400 series logic to be more fun, and some people have looked at me and said, hey, when are you going to make a kit? And so I have to reduce those parts out. So it's, again, a lot of development time. So no real actual use yet. Yet is the key word.
Well, we all know the point of building a computer is really just to get a thing so you can build more computers, right? I mean, so I got started in microchip picks back when you had to UV erase them. And one of the things that always I thought was sort of limiting about them was you were stuck with the I/O that you had, and you could latch out on other ports and stuff. But as my projects started getting bigger and bigger, and before I was into computers, I was into electronics. I started looking at that 8085 board out of the Merlin system and thought, that thing can talk to 256 I/O ports, and it can have 64K of RAM. That really seems like it's got more capability to it. And sort of that's been my use all along, is sort of using the 8085 system, or any of my vintage computers really, as basically digital and analog I/O things. So like you'll see over in the hackerspace, there's a board that plugs into this I made the other day for testing LCD displays, because I had an entire banker's box full of unknown LCD displays. And hey, why not just knock it out in BASIC on the 8085 instead of doing it on the PIC or something? So that's sort of been my use all along, is first of all building other computers, and then second of all doing sort of your typical laboratory experiment kind of stuff with them.
So whether you can, if you can go back to the start and do it over, what do you do different?
I don't think I have a good answer, or I don't think I would have changed anything. The PDP-8 was a good choice at the time. And if the object was to learn and just to have fun, then it was successful. It occurred to me as after I finished that there was something we actually did with the machine that was useful. There used to be a navigation system before GPS, and I can't remember the name of it for some reason. I was just going to try to Google it. No, it was not Loran. It was the other one, the one that used 3 low-frequency transmitters, 10.3, 11 and a third, and 13.6 kilohertz, which I will never forget those numbers. And no, well, I don't know. The way it worked was there were 8 transmitters on Earth, and they were broadcasting. They would broadcast just a tone at each of these frequencies, and they would rotate. Like one would broadcast 10.2, another one would be broadcasting 11.6, another 13, or 13, 11 and a third, 13.6, and then they would all shift over one. So like every 8 seconds or whatever it was, they would have all each played the tone and then had a silent part. And if you had a radio receiver with a sufficiently sensitive antenna and front end, you could pick up, if you were really lucky, 3 of these stations, and that was enough to triangulate. But the waveform was miles long at that frequency, so you didn't get absolute position. You had to know your position within a few miles. And if you knew that, then with this you could narrow it down to, I don't know what yards or whatever it was. And the guy that I was working with on this project, he wanted to, well, his PhD was in low-frequency propagation. So that's why he was tuned into this world in the first place. No pun intended, exactly. And he thought we should make one of these navigation devices, because if you want to go buy one, it's like stupid money. I mean, we're talking like $100,000, or it was a ridiculous amount of money to buy one of these things. He figured, well, we can make them, and then we can sell them, and we'll be rich beyond our wildest dreams of avarice. And so we tried to develop an embedded system using the PDP-8. So we actually built a front end to pick up these signals and then use the PDP-8. And because the signals were such low frequency, we were doing the RF front end with 741 op amps, which some people realize is like absurd, but it's true. They still had a gain of 100 at 10 kilohertz, so you could use them for an RF front end. And the 6100 with whatever stupid clock it had, 2 megahertz or whatever it was plenty fast to sample that. Anyway, that was the actual useful work we did with ours, was try to do. We never actually finished the thing. We got it to sort of be able to sync up to the 3 transmitters, and then we ran out of steam, and he got his degree, and that was the end of that.
So for anybody who in a room might be thinking about making their own computer, what will your advice be? Like, what did you learn? What did you learn from the experience of making your own computer that you could teach others?
If you're sufficiently motivated, you can learn a tremendous amount from building it, and building it can be from everything from scratch building it on perf board with wire wrap, or all the way to buying a kit. And each one of those levels allows you to learn something from the process. And of course, now that we have the internet, you can be an autodidact and learn as much as you want for free. So there's no limit to how much you can learn. I came into this with the advantage of having an electrical engineering degree. So the electronic part of this wasn't a challenge. I knew what I was doing already when I was building the thing. The bigger problem with me was just the ordinary hobbyist limits of how do I get boards made. And I was lucky I was working for a company that had a board shop just for the engineers to go play in. So I could go get boards made in the shop. So I didn't have to home etch 2102 12-bit wide RAM cards. Yeah, there was no Osh Park back then, obviously. Yes, Omega navigation system. You're right. Thank you. Now you've restored that neuron.
All right, your first question about what would I change now from this perspective, the bus layout. Oh man, I would totally shift around a couple of things in that bus layout. I've actually run out of pins, and there are a couple of things that have shifted off of those that 35 wide lane, and I've had to use a bunch of jumper wires, and then I realized no, none of this stuff will exist on the future bus down the line, and it's all going to be consolidated onto a couple of cards. So I can forgive myself for that bit, but there are a couple of things where there are signals, or yeah, maybe I should put this one next to this one so it doesn't mess with that thing, and not really all that overbearing of changes, because it's been an incremental process. Each time I realize I've done something completely terrible and wrong, I can take out that chunk of it and think, all right, well, what else do I have to change if I completely rewire this part of it? And I like that. I've kept mine very separated into each component, each functionality is sitting on its own card, so that if I have to make a critical change like that, I can yank it out. And I like that, but it introduces its own set of problems, of course, as opposed to one monolithic board like the 8085 here, where it's one and it's got its expansion bus and that's it. It's nice and compact. But that also comes with the major difference of his one works, mine has problems still. We're working on it, I swear.
And his is the nice shade of blue and says "Don't panic" on the front.
Exactly. And mine's made up of a variety of colors, not just the wiring, but the boards themselves. Because if you've ever, for those of you who have seen the Cactus, you'll note that it's covered in all these different varieties of Kynar wire. It's a rainbow of colors for me to keep track of the signals. And I've soldered them all in place because I don't have wire wrap tools, nor the pins, the long leg headers. So I was like, well, I can solder. I love to solder. Let's do it this way. And it comes with its drawbacks of, I have to desolder if I want to change something, but I can fit the boards in tighter because there's no long pins sticking out from the back sides of each of them. And it's actually been a surprisingly inexpensive way to prototype, as opposed to digging up those long headers with the square pins that cut right into the insulation so you get a good contact. And some people have told me, and maybe this is right, maybe this is wrong. Those of you who wire wrap can tell me otherwise. You can only get about 3 different things, different wires connected to one leg before you really...
Yeah, three connections to a pin is the rule.
That's what I heard, and after that you apparently start to get trouble. Yeah.
Well, you run out of
Just run
pin.
out of physical length.
Yeah, exactly. So it's all point to point and soldered down where necessary, and that's fun for me, but I don't know if that's fun for everybody else.
All right. Well, my first advice to anybody building their own computer is learn to document your work, because I've probably spent about as much time reverse engineering my prototypes as I did making them. And one of that is proper prototyping technique. So if you're going to point-to-point wire, learn to start baling your wires together and actually routing things out and having colors that mean things to you. Buy yourself some 25-pair telephone cable and get all the colors. And actually, wire wrap is one of the big game changers for me. I had a job in college in which we actually had wire wrap tools, and got started on that and discovered what a life changer that was. Once especially if you're going to lay out a bus machine and you're not using Vero board, anytime you touch that soldering iron to a bus connection, all the wires that are on there lift off. So yeah, that's if there's one thing that I can, and this has been through now 4 revisions, so we know about things we've done wrong. Good prototyping technique and documenting your work. Draw out a schematic, even if it's on a napkin. Save it somewhere where you'll actually be able to get to it. Make wiring lists. Use lots of colors. That's the big thing I would have done different.
Okay. I guess this question really only applies to Jonathan and Alexander. What are your future plans for your computers?
All right, so because people have been asking me, hey, can I have one of those? How do I build one? And my answer is, well, you don't want to build something that's not finished or 100% working yet. You do? I like your attitude. Right now, my focus is to suss out the simple most flaws that I've had remaining. Like I mentioned before, that software front panel switches and getting it no 6522 on board, because that's an expensive chip, and I can do it in 7400 series logic. I'd like to. And then I've still got to actually order boards that are not handmade, so I can see, all right, does this still work afterwards, and then pass them along to a couple of my beta testers. There's one right there.
So this is an exclusive VCF East reveal. You are making a kit?
I'd like to make a kit. No, it is my intention to make a kit sometime down the line. When, I'm never going to say, because the second I promise anything, there's going to have something come up. No Kickstarter for me. That's cheating.
I think you should put the whole design on the web and say, if you want, follow along at home, make the mistakes, follow as I make mistakes, and build it, and comment your corrections, put corrections in the comments, and, use WordPress to slap a blog up with all your work on it, and let it be collaborative.
Well, I do actually have a website now, which is nice. Oddly enough. And one of the things that I would have to do, coming back to Jonathan's suggestion of document well, is I would have to take all of my hand-drawn schematics, because most of my schematics are done in 4 different colors of pen on yellow legal paper.
Photograph them with your phone and slap them up on the web until you get around to using KiCad or Fritzing to redo them.
And I've got a whole pile of these for each successive iteration, and that all needs to be digitized. So that's another thing that needs to happen.
I've talked to Z at some length, because we actually kind of live sort of near each other, about pestering him into to working on some of the kit stuff when he's ready. So yeah, don't expect a Kickstarter, because I think we both agree that that's a great way to get yourself in a real deep hole. But yeah, that's something we've talked about. So as much as Evan would like to squeeze it out of Z about when it's going to be done, it's up to Z. But
Online, warts and all.
Some of it is.
Photographs of your schematics, throw it up, and just let it be stream of consciousness. Like yesterday, you saw Rev 3 of this board. Here's Rev 4, and here's a new photograph of another napkin.
Some of it is on there. There is a secret dev blog out there somewhere that has all of my angry rantings when I realize my own personal mistakes. So I can point out to myself later on down the line, hey, stupid, you did this. Don't make this mistake again. It's me just talking to myself and like the 5 people who actually read it.
That was true. When I was working on my Lego robotics thing last year, there was one part of the code I didn't understand, so I Googled and found a website with the answer and realized it was mine.
That happens.
I forgot about it, yeah.
You'd be surprised how often I find myself looking up something like that and come back to my own work, and I'm like, you kidding me? Nobody else has an answer to this question? And my answer is wrong? Oh, okay. Yes. That's true.
That's what I'm saying. Show it all. Show all your work from the beginning.
Considering how fast some of the revisions change within the span of a couple of hours.
Well, okay, not every single by the second. Not a live video of you making the thing.
Actually, I've done that before. Occasionally, I film myself soldering up a board.
Real-time soldering.
Yeah, just because people are curious. I put a camera on there, and people will watch it and go, what are you doing?
So John, did you have anything else about your future plans for it?
Yeah. So but before Innate VEM stuff was really coming together, and before it imploded, and before RC 2014, and way back in like 2008 or 9, that's when I sort of thought this up. And actually, the point isn't to make single board computers. It's just Evan asked me to do one for a couple years ago, and so we did. I designed the bus on this because I got tired of building RAM boards for every processor that I wanted to interface to. So the ultimate goal of this is to have both a stacking system like this and a backplane where you can have as many different CPU boards as you want, but you don't have to change your RAM, your ROM, your serial port, and all that. That is the ultimate goal, and that's why the bus on this may not seem as super straightforward as it could be for the 8085, is because it's meant to talk to other processors. And it's one of those things that we've sort of talked, me and several other people, including Z, about, wouldn't it be great if you could expand the RAM on this single board computer from the 70s, like, say, the Chem 1, or the OSI 400 board, or the Lawrence Livermore trainers, or any of that. And part of that would be basically anything to glitch bus bridge. So that's really the point of developing all this, is to have a system that actually works to develop this other stuff for other, getting back to that thing about how computers are only for building other computers.
Okay, so we have about 13 minutes. We'll take some audience questions, and at the end, before you leave, I have a couple of housekeeping notes. In the back.
Sure, yeah. So the question was about the software used for layout and all the way up to the actual fabrication of the board. If you're a hobbyist or a serious professional who doesn't have like $100,000 software budget, and you're not using KiCad, or everybody's apparently saying a KiCad now, which is, KiCad is a product from the 80s. So KiCad, the one that CERN is developing, is the thing that you should be using. Yes, it has a learning curve. Yes, it feels like QCAD from the DOS days at some points, but it is the thing you should be using. It's free, it's open source, it now has CERN developing behind it, so you're starting to get real quality libraries where the parts actually match what they actually are, instead of, say what? Oh yeah, it can do differential traces now. It has microwave tools, which probably isn't relevant to most people here, but yeah, if it is a professional enough tool that you can build, blinky light board for your 8085 system, all the way up to, there's a guy doing ball grid array FPGA development that I personally know of. As far as actually getting prototypes made, Osh Park is of course the big one here in the U.S., but this size board, the mezzanine here, run at Osh Park in quantity 3 will cost you like $100. Basically, China's fighting for your business now. There's a board shop place called PCBshopper.com. You go there, you put in your dimensions and your tolerances, and they'll actually arrange all of the prices based on who's running specials at the moment, how many you need, what color you want it to be, all sorts of stuff like that. So, like, really, we couldn't be in a better time for doing homebrew computers, because the resources for it are so cheap and accessible. And if you don't know how to use any of that, hop onto the Vintage Computer forums, which of course Vintage Computer Federation runs now, and just ask, because all of us are on there, and we're all eager to help you do this kind of stuff. So if you need help choosing a circuit board layout tool, or help with a footprint on something, or running boards, just reach out to the community. That's your biggest resource nowadays.
I would like to add that if you want to slap together a small board and you don't want to go through the KiCad learning curve, you can use Fritzing, which is a lot easier to use, but it's a little Mickey Mouse. It's just gone through a period where there was no development, but it's coming back. There's a new Java-based Fritzing available. And it has cross-platform, though, so there's that. And the other problem with Fritzing is it's nearly impossible to create your own library parts. So, but I used it to make several boards, and if you just like making a little stupid thing with a 555 and some R's and C's on it, you can pound it out in Fritzing in 10 minutes. And it has an auto router that's usable. So, just saying, if you don't want to go through the KiCad learning curve, because that's a lot harder to start in KiCad.
I have a question for Stephen over here. I'll put you on the spot. You work at FPGAs. Yes, not in them, yes. You wouldn't fit. What would be the arguments not to do it this way?
It's a very good point, but part of it is actually just a slippery slope, right? So FPGAs, instead of burning boards, wire wrap, and all the rest of it, it's code, right? You write down system Verilog, HDL, don't choose your place or whatever. But it's a pain, right? It's less of a pain than having a board made or wire wrapping and discovering, oh wait, no, I connect that to the wrong one, discovering three pins away. All that stuff goes away. You're still left with, oh geez, did I get the timing right on that? Is that happening to this clock cycle? I can connect clock cycle and so forth to do that. And it's a hassle. But if you're going to do that, why not run a simulator on a $5 Raspberry Pi where somebody else has written all the rest of it and you throw it together very easily? So it's actually a problem that I think about a lot with my students. Where do you put the resistance? Where do you put the stress on it? Right? And so you guys, it sounds like you especially are trying to use vintage TTL components and all the rest of it. And that's just a particular challenge. And hey, you want that challenge or don't you? Well, you can skip that and use gals or something like that, or you can skip that and use CPLDs, or you can skip all of that and use an FPGA, or you can skip all of that and use something off, use a Raspberry Pi or some other SoC or what have you. So it's really just, do you like the smell of solder in the morning? It's kind of my view.
We have time for one more question. Dave?
So I'm a systems engineer, so I do.
Okay, so the question is basically, how do you design and debug a relay computer? And I would guess with current tools, being as how relay logic is a pretty old thing, you're going to do that on paper.
I'd write a simulator. I'd write a simulator if I couldn't find one that did the job. I'd write a simulator.
Yeah, and that is an excellent point. Is Logisim is a free open source logic simulator where you can lay out all of your stuff in it's a Java based thing.
I actually use Logisim quite a bit to figure out the subtleties of things. So I can imagine that would scale up pretty well if you knew how to build those building blocks of and or with relays. You could certainly scale that up and obfuscate a little bit within that until you get down to brass tacks and physically wiring point to point. But yeah, I use Logisim quite a bit. In fact, I was just using it 2 days ago to figure out the subtleties of my software switchboard.
So that's all the time we have for the panel. I hope you guys enjoyed it. Thank you. And we'll enjoy the rest of your day classes, and we'll see you all tomorrow for the main show. It does? Okay. Oh, okay. Well, feel free to come meet the inventors and see their computers. Yeah. Or ask more questions.
If you want to let me ramble, I can ramble for a while because I've got some.
Why don't we just have people come up here and ask questions? So that's.
This running on the Monster 6502 is really cool.
Oh yeah, you saw that.
Are you going to give a Monster 6502 a run?
All right, so here's the thing. Those aren't in production yet. All right, he was asking about the Monster 6502, and for those who missed the video, at VCF West back in August, I had the pleasure of being the first machine not designed by Eric Schlaepfer himself to be connected to the Monster. So Cactus Monster, it was a beautiful thing, but it has to run at 50 kilohertz. That's it. So there's a special board to clock down, and it was a beautiful thing to watch after I figured out that I needed an extra buffer on the read-write line because it was clobbering stuff. And when those go in production, I imagine those are going to be a little expensive, but honestly, I wouldn't mind having one of my own to keep around and plug into a Cactus. That'd be a lot of fun. But I don't know if... Oh, yeah. But here's the thing. The Monster can only work, obviously, at that short little range of clock frequencies. I think it can go as slow as... gosh, it's only... you can't single step it. You have to go as about as fast as, like, 12 hertz, I think, is the lowest, but you'd have to ask Eric for the specific number. But the fastest it's ever gone is 60 kilohertz, and a lot of stuff is time dependent for graphics rendering. So you have to have something separate where it's going to be able to wait for that slow CPU to operate. We spent a lot of time discussing it at length beforehand, Eric and I, to make sure that we weren't going to have any fires and blow up his, far more time.
Came in late. Is this a steam-powered 6502? Or
No, it's the Monster 6502. Excuse me. Yeah, I should have mentioned that. Is what happens if you take the die of the 6502 and explode it to about this big. So. Yeah, I don't recall the exact dimensions.
is it built with discretes? I mean,
Yes, it is.
It's built with transistors.
Yeah, it's done in individual transistors where possible. Now, the combined type of transistor that he uses is still not as the type that you would expect, but it's all surface mount because of how big a non-surface mount one would end up being. I think it'd be larger than this table, and then you'd have issues with capacitance and a couple other things.
And he put lamp registers on basically all your internal registers and everything, so you can actually visually watch it run. Beautiful. It is.
It's pretty amazing.
It really
yeah.
is.
If you haven't seen it, go check it out on YouTube. It's a thing of beauty.
Yeah, and a little related plug. Our museum will be open tomorrow and Sunday, and there's a display case in there where we have a 6501 chip.
One more thing about the Monster, that right now they're on the second revision, if I remember correctly, and that one even has the LEDs to show you the instruction decoding. The first version doesn't have that. It does have all the original bugs of the six. I don't know if I wouldn't be surprised if it even does the undocumented opcodes as well. But you'd have to ask Eric about that. It's his baby, not mine. I was just happy to be in the presence of it and touch it.
So the question is, so the question is, hey, can I just make my own silicon at home? And probably you guys have seen Sam Zeloof do that, sort of. And Connor Krakowski will be here tomorrow, and he can tell you about his trials. I actually work on the control systems that make chips, and let me tell you, the chemicals you need for that are not something you want in your basement. Oh, the photoresist is worse than the HF. There's some really nasty stuff in the process. But if you are actually interested in microlithography, photolithography, things like that, there's an entire industry that needs more engineers like you. Yep. Yeah, I think that's it.
I believe Herb has a comment. Yep. Herb has a comment, Dad.
Okay. Yeah. So yeah. The point of doing all this is, of course, to learn something about it. Because if you didn't care about learning anything about it, you just go buy a thing off the shelf or use a modern computer. Yeah, and it's one of those things. I studied computer science in college, and you can read about it in textbooks and whatnot. But playing around with all this stuff, I actually knew how it worked under the hood. Even though I might have had colleagues that could have memorized the textbooks better, getting your hands dirty, actually building a thing and doing it wrong 5 times and learning why it's wrong and seeing it on the oscilloscope why it's wrong is a whole lot different than reading about processor design in a book, and I highly recommend it.
I studied computer science as well and focused primarily on the software side, way detached from the hardware. And really, there was this sense of curiosity about something so nitty-gritty where you can touch an individual bit. There was something fascinating about that. And I found that in the process of building the Cactus, my skill set of diagnostics and building something, repairing something that's vintage instead has improved dramatically. I'm not as afraid of an oscilloscope anymore, and I know which end of the soldering iron to hold to put something back together. Not too long ago, I acquired a machine that needed a little bit of help, and the process that it took to bring back together only took about a week and a half, when previously, I mean, that would have sat on my shelf for a year as I slowly figured out each piece of the puzzle. So it's really giving me skills to look back on my vintage collection and help those out and bring those back to life as well. So yeah, the learning process helps preserve the history.
Okay, I think we're done. Do you have a question, sir?
Yeah. What's the most useful tool you've gotten to design and build?
The most useful tool that I've got to design and build that I've discovered is other people. The knowledge and experience that I lack, being able to talk to somebody who does know something so that I can learn from them. It's flesh and blood. It's to be able to talk to a friend and work through a problem. It's not some physical piece of kit or a software or something like that. It's friends, really.
I've got one that's a little less. I mean that's actually the better answer. There is your best resource is going to be the community, but the best thing that you can write in software is a monitor. Yeah, your raw monitor. If you don't get that at least a little bit right, you're not going to have a good day.
Okay, I think we really are done this time. Sorry for the false starting earlier. Okay.